Before I show you the csound related stuff, I'm going to talk a little bit about why I did this at all, why I wrote quince, and why it came up the way it did. And then I'm going to show you the overall structure of the program and do a few examples, and then we will come across the csound related parts of quince. It all started in 2006 when I was starting to. I'm a composer myself, so I'm actually not that much a programmer or computer expert or anything. I'm just a composer, mainly of instrumental music, actually. And in 2006, I started to work with transcription, with the translation of recorded sounds into musical classical 5-line system notation. But what I didn't want was to use automated, like WAV to MIDI software or something, where you put in an audio file and you get musical notation back. I don't think that's the way to go there, because I view the process of transcription as a compositional act, and I want to choose what's important and what's not. And I see transcription as a method to perceive perception, because if you listen to something that I transcribed, you will listen to what I listen to, because I made choices depending on what I actually hear subjectively. So I needed some kind of tool to enable me to make these choices. If you want a kind of an aid for ear training, I needed an ear training aid. And I wrote my first app called MTC. It was really, really very basic and badly written. I learned how to do it while I was doing it. And I could throw in an audio file, and I could see the envelope, and I could run some peak detection and get some rhythm and drag events around and get some output. And then MTC fell victim to what a very funny columnist of the New York Times described as the software upgrade paradox, which is if you improve a piece of software enough times, you eventually ruin it. And that's exactly what happened to MTC. It just imploded. And then I had to decide what I was doing, and I decided to start completely from scratch and do it right this time. So I'm not sure if I succeeded with doing it right, but that's how quince came into being. And there were some basic thinking thoughts about software and art involved there, because every software is hierarchical in a way. There are always things that are easier to achieve than others, and actually this is the point where programmers take responsibility from the composer and make decisions about what the composer is likely to do and what not. And I'm not okay with that, actually. I want to decide that for my own. Also, I'm teaching Max MSP, and there was not one class in the beginner's course where some student came with a looping. For those of you who know Max MSP, a groove and waveform stuff, and hey, I can drag loop points around, and what a great idea! And really, they sometimes really think it's their idea, but it's actually not. It's the idea of some Max MSP programmer who thought it would be cool to simplify these things. So when it's difficult to decide what you really want to do in the first place, now there's also software determining how we use it and blurring our vision of what we actually want to do. So I had to build some environment where everything is flat, no hierarchy, everything flat. I decide what's important and what's not, as the user actually. That was the first important thing about quince. The second thing was I really didn't like the thing that I had to rebuild the whole program, MTC, the first version, to add new functionality. It's a pain, and it's you have to recompile everything just to add a tiny little little new functionality. I didn't want that. So it had to be plugin based. Everything had to be a plugin. So actually in Quince, everything that fulfills a significant task, every tiny little bit is actually a plugin. Views, players, functions, everything is a plugin. And the other thing was, the third important thing, that I had a strange feeling towards the tape recorder versus mixing desk paradigm. Every digital audio workstation, in essence, is a mixing desk and is a tape recorder. They're pretty much the best option for a lot of applications, but there are situations where you just can't use them. So I needed something else, and I came up with Quince, and I'm going to show you now how it's working. Quince, actually, the name. I think you're familiar with the fruit quince. Yeah, and the thing is, if you just hold a quince and you're happy and you bite in it, you won't have much fun with it. So because it's hard and sour and everything, and you have to know how to deal with it to get something delicious out of it. So it's the same here. Okay, so there are two windows in Quince that are important. This is the project window where all the dragging and editing takes place. And the other window is the pool. And the pool is the place where all the data and all the functions come together. Now, Quince is not media-centric. The only constraints about data types is that they have to be time-based. That's it. It's a completely abstract layer we are on. And the only thing, actually, there are even exceptions to that rule, but basically, it's about editing sequences of events in time. That's it. And an event is just a collection of parameters, and the parameter is just a key and a value, like an identifier, a name, and some kind of value. It can be anything really. I'm creating an event, and actually I just did like four or five things at a time, so I have to go back. But by double clicking, I can open the object inspector, and we now see the default basic parameters of this object. It's a start, a duration, in this case a volume, a name, and a description. No? It can be really anything. Now, in Quince, there's actually no difference between an event and a sequence. It's just a question of perspective. You can see it in the pool that we just created a new event. I'm going to call this A, and we can open this object A, and we have another object here. It's called object B. So every event can have one parameter. It's called sub-events or sub-objects, with a collection of other events. So from this perspective, it's a sequence, but from perspective of the child, so to speak, it's just an event. So you see that in this strip, I'm going to explain it in a minute. We loaded the object A, and this is not the object A. This is the object B. The little blue thing here is the object B. So what we're actually doing, we're looking inside the object A, and we see its contents. In this case, the sub-objects. And this can go to any level. We can build object hierarchies with any depth, and also can create another chart here. And now I can select them both and fold them into another sequence, just by the push of the button. Now I have a new sub-object, and the little red number here shows the number of sub-objects, and in the pool we can see the new hierarchy. Yeah, so you're looking into A, and A has one sub-object, and which has another two sub-objects. Okay, now these things here actually are not are not channels. They might look like channels, but they're not channels. They are, I call them strips, display strips, because they are just some areas where data is being displayed. And in these strips there are layers which actually display the data. So it's just like in Photoshop, you can have multiple layers on top of each other, displaying various kinds of data. For instance, we could create a new strip, and I'm going to explain that in a moment, and load this object, this sub-object, into this strip. So now we are looking into A, and down here we're looking into this sub-object. So if I move this, the objects below move too, and if I move this, I change the duration of the first one. Okay. And about layers, I can add a new layer and do some stuff here. And there's absolutely nothing to do with this one in the back. I can't touch it anymore. The layer is not active. I have to go back to the first layer, and I can do this again. Okay. Now, the thing that is actually displaying the data is not the layer itself, but a view that's loaded into the layer. And this is what I did using the menu here. There's a set of plugins called container views that are used to display various kinds of data. Automation container is made for displaying automation data, although there's no player or nothing there that can actually use automation data, but at least you can look at it. There's a send container displaying send deviations, an envelope container for volume envelopes, frequency standard container for the frequency in a linear way on the y-axis. Glissando container is where you can edit glissandi. Mark container just for markups. Pitch container, now logarithmic frequency. Pitch curve container, pitch, well, curves. Pitch grid container for quantization. Time grid container for quantization, and the volume standard container where you have the volume on the y-axis. And actually, these tiny little these boxes here are plugins too. They are child views. And the behavior of those child views is determined by the implementation of the plugin, so it's all kind of optional. Okay, now if you actually want to work with data, you need to operate on it. You need to be able to manipulate the data. And this is where functions come in. Here on the left side we have all the objects in our session, and on the right side we have the functions, also plugins. Now, if I want to execute a function, I have to double-click on the function name, and then the function loader is open. And the function loader is an instance between me and actually between the function and and the objects. The function loader knows what input the function needs, what input it expects, and takes care of things so that everything is loaded correctly with the right types and everything. In this case, the function legato, which is meant to extend the durations of objects until the start point of the next one in the same sequence, just needs one input object, the object it's supposed to operate on, nothing else. But there could be functions that needed more than one input object of the same type. So there's this purpose slot in the function loader trying to clarify what the object is actually meant to do in the process of the function. Functions that have one single input object of type quince object, which by the way is the most basic object type in quince, are also available in the selection menu. So I can select something. Okay, I'm going to hide this one. Thank you. And select the legato function from the menu. Oops. Something went awfully wrong. Okay. So done. Now, and I'm going to show you another function so that we can do something more exciting afterwards. There's a function called align on volume. And align on volume sets the parameter volume of all sub-objects of the input objects to the volume value of the first object. So align on volume does this. So now there's one feature in Quince that lets you combine functions in a way similar to the way we've seen objects being folded into sequences. And it's called a function graph. They are built with the function composer. And using the function composer, I can always combine two functions at a time. So I could say I want to use the function align on volume, and the output object of the function align on volume should be the input object of another function. In this case, legato. So there's, as I said, it could be the case that one function needs more than one input object. So here's where I can choose which slot of the second function I want to connect the first function with. In this case, there's only one option, and I'm going to name this align legato. Okay, now in our pool in the function section, we get one new entry down here, align legato. It's actually a little XML file on disk somewhere describing the connection. That's all. And I can I think I have to rename my object into something meaningful, like test. Okay, and now I can execute my new function graph on the object test. I'm always doing this very quickly, but you have to select something in the pool and then click on load for the function in order to get it. And action, and so the both functions have been executed at once. And since function graphs actually behave like functions, you can combine functions with function graphs and function graphs with function graphs, so you can build theoretically very, very powerful big tools. The problem is actually naming them. I just had for the first time a problem with that, as you see here. It's a big load of functions I wanted to execute in one step. And you actually have to keep the function graphs you used to build the complex one. You have to keep them. So it's going to fill this function slot with function graphs, and in the end you have some big long worm names. Okay, that's the function graphs. Now, so far there are 5 object types in Quince. The first one is a Quince object. It's the most basic type. It just knows some bits about being an object. Then there's a data file, which is simply a pointer to a file on disk, an audio file, a pointer to a file on disk that knows about being an audio file, an envelope for volume envelopes and a pitch curve. That's it so far. In the future, it's planned to make types also available as plugins, so that you can actually build new type definitions into Quince. That would be nice. Okay, we'll see the types in a moment. Now I'm going to add a new audio file, just by clicking on new audio file on the bottom and selecting one. You see, I get a new object. It's called like the file on disk, and it's of type audio file. And it knows nothing except where the file it's pointing to is, and that it's of type audio file. In a normal DAW, we are used to drag sound files into our editing area, and we talk and behave in this environment as if they were actually audio files we're working with, but they're actually not. They are just references. In Quince, this is made explicit. You have to tie these objects and files together yourself. So if I want to create a reference to an audio file, there are two possibilities, but in essence you need to create a parameter that with the identifier media file name or audio file name, with this object's name as its value, so that some other object, function, player can ask the object, what is your media file? Give me the name. Then I'm going to the pool and ask the pool for this object, and then I'm going to do something with it. For instance, play it or something. And as you see on the right side, most functions cannot deal with audio files. No, everything is gray except for one, and this is audio to envelope. So I can convert this audio file into an actual volume envelope. Now I have an envelope, and I want to see it. And let's just okay. Now I had to switch the container. It was set to another container, and the container loaded couldn't read volume envelopes, so he had to say something. So this is the envelope, and it actually it's not a waveform. It's an envelope, and it's windowed, and the amount of detail we see is dependent on the zoom level. So if I zoom in, the display gets more detailed with tiny glitches too. What do I see? Okay, Quince is not bug free. It's in a beta stage, and I haven't decided yet when to call it off. So it's going to stay in beta as long as I think it's necessary, but it's not bug free. Actually, I was fixing bugs just 5 minutes before you came in. So this is a volume envelope, and one workflow that is one use case that I do a lot is to create another layer on top of it, and to create little events where I think there should be any. Now this can also be automated, but I like to do it myself. So this could be one way of doing this. We could also use some data of other programs. I haven't built an internal frequency analysis, but I can read frequency data from Spear or from Praat, maybe Praat and Spear. And I prepared something. Okay, I made a short analysis of a flute piece from Burkina Faso, and I created a text output from Spear, and it's on disk, and I can import it using the function import frequencies. Ta-da! Now it's reading the text file, and it's creating a sequence with one object in it for every slice of the FFT. I'm going to name it BF, Burkina Faso. Okay, we can see it now. So it's actually loads of objects. Much too many, actually. So to reduce this kind of data, and we can see it in actually we can see it in 3 dimensions if we want to. Okay, so now here we're seeing the volume, here we're seeing the pitch, and we can also get a closer look, maybe like this. Okay, a little better. But it's just too much data. So what I can do is I can try to join frequencies that are in a certain range, in a certain frequency range. I can say like 25% of a semitone or something. There's a function for that called join by frequency. Let's do this. Okay. I should have done something else first. I'm just going to kill it instead. One other feature of quince. Most of the time, you get your session back after a crash. Depends on the time interval between the autosave and the crashes. Okay. Yeah, I think I'm reducing it to the loudest slices of the analysis, so this is going to be much faster. So and now, okay, looking at oops. Okay. Now I'm going to join subsequent events together. Okay, it's tone. Okay. Yeah. Okay. So now we have this looks okay. Here's the pitch. The same thing. Okay. Now we can get a closer look to the pitch. Let's say 76 and I don't know 90 maybe. Okay. So this is volume. This is pitch. Now to make sure we really have the right pitches, we could create a pitch curve from the sequence. So I'm going to use the function called sec to pitch curve with our maybe with this one. Okay, now I have a pitch curve. I can create a new layer with a pitch curve container, load the pitch curve, and we can see the pitch curve. So this is, for me, this is very useful to have multiple displays on top of each other, and not on top of each other. Yeah. Okay. Now about quantization. So far there are two applications for quantization in quince. The one on the time in the time axis and one on the frequency axis. And to actually quantize something, I need another sequence. I need a sequence is always being quantized to another sequence in the parameter. And I could basically use any sequence, but to make real sense, I could create a grid sequence. And there's a function for that called create grid sequence with two tabs, time and pitch. And being an instrumental and traditional composer. This is based on integer dividers of a quarter note or a second. So if this is a second or a quarter note, this would be eighth notes, triplets, sixteenths, quintuplets, sextuplets, and so on. Yeah. Okay. So I can create a little grid, maybe sixteenths and 32nds. And I get a new sequence with a sub-object for every grid point in the grid. We can actually see this in the time grid container. Okay. Now this is the grid I just created, and the red lines are the actual grid points to which objects would be quantized. And the colored areas are the areas from which objects would be quantized on the respective red line. So if I had an object here, it would probably end up there with the direction changed to this. So it quantizes in both the start and the duration. Okay, same is true for the pitch. I can create a pitch grid. Create pitch grid. So far only on temperate scales, but who knows? No? And let's say we want eighth tones. Okay, pitch grid for one sub-object for each possible frequency. And now I can quantize my sequence. And I think what I want to quantize is this one, right? Okay, so I'm going to ready for quantization. Okay, and whoops. Okay, that was the autosave. So I'm going to do the time quantization now. Load the time grid. Load the object I want to quantize. And go. And it's actually non-destructive. I'm getting a quantized copy of my original object. And we can see now that they are perfectly aligned on the red lines. Now, since I only want one voice, I'm going to reduce this again to the loudest parts of it. Okay. Here we go. And now I'm going to quantize the pitches as well. Pitch quantization right here. I want to quantize this one with my pitch grid. Here we go. And now my pitches. Oh, sure. Yeah, my pitches are quantized to actual eighth tones. And now this can be exported to some. And this is actually why I do this most of the time, is because I want to work with this material. Sorry, which one is it? This one. Maybe you know Lillipon. So I can export this to Lillipon code. Let's say I want 120 BPM. I want pitches. I want nothing else so far. Let's say okay here. Open it in Lillipond and get this. So this is one direction I very often go, and I can add multiple parameters to the Lillipond output too. If for instance, I want to know something about the volume, I want to know about dynamics, I can map dynamic expressions to the volumes of my sub objects, like this. I can enter individual values or enter the distribution, change the distribution, spread, map it, and now every sub-object here has a parameter named dynamic expression with an appropriate value. And if I just export this one to Lillipond and say that I want dynamic expressions on the bottom, I get hopefully dynamic expressions on the bottom. Yes. Okay. So, and we could actually add various other parameters, for instance, cent deviations or descriptions to it, and get them on top, written on top of the notes or something. So this is one direction. I told you before that that quince objects can represent audio files, and I'm going to show you how this is done. Maybe I start a new session. Okay. When I load an audio file, and if it's selected in the pool, there's this little text field here showing the name. If no audio file is selected in the pool, it's showing no reference. And as long as I have this selection in my hand, so to speak, every object I create here automatically gets a parameter called media file name with the name of the selected object as its value. So there's automatically a reference to this audio file object. Okay, I think one is enough for now. Oops. Okay, so now I have a reference to an audio file. So if I choose a player plugin now that can read audio files, it should be able to play my audio file. Down here on the left side, there's a menu for player plugins. There are only two available: the audio file player and the csound player. And the audio file player is doing just what I just said. It's playing back media files, audio files in this Okay, so if I hit play, now we are hearing the audio file. This is the example where it's quite related, quite common, and quite similar to the normal DAW way. I could add a parameter called media file start to add an offset into the file, but basically this is it. There's another feature, another way of dealing with audio files. If an object does not have a media file reference but is asked for one, it automatically asks its mother object to give it hers, so to speak. So if I have an empty object, no, I need an object with an empty object with a reference to my audio file. So I'm selecting the audio file here and going for new object for audio file, and now I have a new empty default object, but with a reference to this file. And if I load this into my view, you see nothing because there's nothing in the object. But now if I create sub-objects, they are interpreted as, so to speak, as windows into the audio file. So if I play now, it's as if the audio file was lying behind my timeline, and I could choose which points I want. Which, in combination with the envelope view and the time grid and the ability to drag around objects, is exactly how I work when I transcribe something. So I can listen to what excerpts I want in my piece, and how it's actually sounding, and how it's going to be quantized onto the grid if it makes sense to be exactly there or whatever. Okay, I hope I haven't forgotten anything important. So we can have a look at the csound player, and the csound player is an actual instance of csound wrapped in a player plugin in Quince. And if you go on settings, you get the very familiar org and score tabs, and the csound score representation of the visible events. And actually, what's being played is, that's true for all players, is everything that's visible, except duplicates. Duplicates are not objects that are that are loaded in multiple views are not played double. Please excuse my English. Okay, so there are four basic default orchestras here, audio files. That's actually the same thing that the audio file player does. Just clicks, just for getting the exact rhythm of the events. Glissandi, if I have glissandi in my sequences, and pitches, simple sine tone. And this is done. The default mode for events is chosen here. Like I want glissando. No, I want pitches. Done. And I think I'm just going to use a new strip. Pitch container, and I create some object here. Play. Yeah, beautiful, isn't it? Okay, maybe not that loud for the. Much better. Okay. So every object I would create now is going to be played with the same orchestra I chose from the drop-down menu. But maybe this is not what I want. Maybe I want clicks and sine tones. So there's one parameter that actually overrides the default csound orchestra, and it's called csound mode. And if I add the csound mode and say I want it to click, I hope I'm going to hear click. Yeah. Okay. So if I want to stay in the default csound orchestra mode world, I can override I can override this, but I can also override it to a parameter that's called csound instrument number, and add my own custom instruments. And I can, if I want to, I can add them right here, and the csound orchestra is saved with the session. So the thing is that Quince is kind of for me it's like a docking station between the electronics and the instruments, and is a place where I can manipulate data in all kinds of orders and all kinds of directions. And I think about my thing in developing software. What I really like is to build tools that open doors where before only automatic solutions were available. So where I can actually gain responsibility. I like to be responsible for my decisions, and I want to create tools that enable me to make my decisions. So there's lots of stuff to do. I want open sound control. I want a decent pitch detection. I want FFT. I want all kinds of stuff. But this is it so far. Thank you. What I forgot to mention, it's open source, and it's unfortunately only available for Mac OS X so far. It's written in Objective-C. Sources are available on GitHub if you want to have a look.
Question.
Yeah.
I'm Mike Hawkins. It wasn't clear to me the relationship between the functions and the objects. When you run the thing, does it execute the functions every time you run it?
No.
So you only execute the functions manually?
Yeah.
Okay.
Yeah. Actually, I have been asked similar questions a couple of times. If it would be possible to build something like a function player, so that an event when it is being played executes a function in real time or something. I think that would be an interesting idea, but it's not possible right now. It's really coming from the offline world. Although it's using csound in real time. Any other questions? Okay then.
And can you show more examples how it sounds if the sounds transform?
Well, the thing is that
or maybe
Quince,
even a part of a composition of yours.
yeah, maybe I can. Let me see. Okay, wait a second. The thing is that actually Quince does not sound. You have to Quince uses other applications to deal with sound, but I can show you one. Actually, example. It's not sounding too, but okay. Maybe this. Yeah, this, for instance, is the transcription of some neighbors of mine renovating their flat with a, I don't know the name, like yeah, you know.
Floor sander.
Yeah, floor sander. Yeah. And you have the pitch curve here and some erratic glissando. Yeah. And in the end, yeah, that's it. And you have the time grid here, so I can see how it's fitting on the time axis, and in the end I get something like this. Yeah, with cent deviations and quarter note stuff. And it's really not a pretty sight. I mean, it's not very beautiful. The Lillipon output. So that's actually when I'm working with this, I'm going to the paper and work with pencil again, and it's going back into the computer. Yeah, I mean the examples I could show you pretty much all look like this, and do not really sound very interesting. So. Thank you. Okay. Again. I'm going to talk about Quince, kind of editor I developed, and I'm not a programmer, a computer scientist or anything. I'm just a composer with special needs, which I'm going to talk about. And I started. The history of Quince began in 2006, when I began to work with transcription, with the translation of recorded sounds into classical 5-line system notation. I didn't want to use automatic rough to MIDI translators or anything. I wanted to do this myself somehow. So it's the ear training session for the advanced, so to speak, and I needed some tools to aid me in this process. And I started to write a little piece of software called MTC, which thank God I didn't publish. And and I could. It was very, very simple, and I could drag an audio file in it and see the waveform, and not the waveform, but the audio envelope, and click some events on it, and drag them around and get some output. I used to improve it and to work on the software a couple of years, and then MTC fell victim to what David Pork from the New York Times called the software upgrade paradox, which goes like this: if you improve a piece of software enough times, you eventually ruin it. And that's exactly what happened with MTC. It just imploded. At some point I added a feature and nothing worked at all. And I had to start from scratch and do it properly this time. And so I decided to put away my compositional work for 6 months and do nothing else but to develop software. And then I started to think what I like in software. How can I make it as allgemein.
Normal or as usable? Or?
Sorry?
Normal or?
Allgemein as
ordinary.
No, not normal, but now how can I formulate my problems so that many other people could do something with it? You know?
Yeah.
So, and there were some ideas that I came across and that I had. One was that every software is hierarchical. In every software, there's some things that are easier to achieve than others. Be it that they are easier to reach in the menu structure or whatever. And this is the point where the software developers take part in aesthetical decisions when it comes to software which is used in creative applications. So I didn't like this idea at all, that some programmer whom I don't even know decides what is important and what's not okay for me. So I had to find a way to create a flat hierarchy where in the beginning actually every function is just lying around and I can pick it up. The second thing was that I didn't like this idea of the DAW mixing desk versus tape recorder paradigm. Every DAW in essence is a mixing desk on the one side and the tape recorder on the other side. It's perfect for situations in which you want to mix some tracks also, but in many situations it's just not working at all. And the third thing was that I had a problem with this, with the fact that I had to rebuild the whole program every time I wanted to add a new feature. Every time I wanted to add a tiny little something, I had to recompile the whole big thing and make a new version out of it. I didn't like this. So I wanted flat hierarchy. I wanted a plugin-based structure where basically everything in the program is a plugin, and I wanted to implement some kind of new paradigm, new working paradigm that's beyond the mixing desk to the I don't know what. And what I came up with is quince. And one thing about quince, the name, is, do you know what quince means? It's the fruit. It's this this delicious. You know it? Yeah. Okay. It's similar to an apple, but it's not an apple. It's very sour. You have to. Sorry.
What's the German name?
Quitte. It's quitte in German. It's coin in French. You have to cook it to make something delicious out of it. No, okay. If you confuse it with an apple and you just bite in it, it's not going to be much fun because it's very hard and sour, and you have to cook it to really enjoy it. Yeah, you should check it. So and the same is true for the software. If you just open it and you expect some kind of DAW, you will be disappointed for sure. So you have to know what you're getting yourself into, and you have to really know what you want to do for quince to be the suitable tool for you.
English and Norwegian?
Oh, bitte? No, I don't know.
No, but this is German. Do you have Norwegian?
English like dictionary?
English to Norwegian.
Oh, Norwegian? Oh,
Yeah,
I thought I used
no.
for German.
Yeah, that's because he is.
Oh, right.
But it's not important. It's not important at all. I can check it out.
Yeah.
Sure.
Okay. And in quince there are two windows that are important. One is the session window where all the editing takes place, and the other one is the pool where the data and functions come together. Quince is not media-centric, so apart from the time-based constraint, there's no limit to the kind of data quince can process, because quince is essentially an abstract layer that uses reference to data files, and if it's a video or a phone call or an audio file or some shell script that's going to be played or executed, it doesn't matter for quince, as long as there are plugins able to handle it. As long as the data is time-based, everything can happen in quince. And so essentially, quince is made for editing sequences of events in time. And an event in quince is just a set of parameters. When I create when I create an event, I just have a list of parameters, and a parameter is just a key, some identifier, and a value. It can be anything. And what you see here is the graphical representation of an event in a layer. And the layer is hosted by a strip, and I'm going to explain this in detail in just a minute. This is not a channel. These are not channels, actually. Now, in quince, there's actually no difference between an event and a sequence. It's just a question of perspective. What I did when I double-clicked here to create this tiny little thing here, I actually created two objects, two events. I can show you in the pool. We have one object, it's called, rename it to A, and it's loaded in this hosting layer. And this contains one sub-object, and that's actually this one. Oops, now we have another one. Okay, now we have two. No? Two little objects. And from the object's A view, it's a sequence because it contains sub-objects, but it's the same object type and the same. It's the same object type as the sub-objects, and from the sub-object's perspective, they are just events lying somewhere. But they themselves can also contain sub-events, so they can become sequences as well. For instance, I could fold them together to form a new sequence. I can select them both, and with the push of a button, I can make a sequence out of them. So now I have one additional layer in my object tree. Now I have the A, which we are looking into. I have this untitled, and this contains 2 additional objects. And this can go to any depth. Now I just said these aren't channels, and I'm going to show you how this is actually working. This is I call this a strip. This is just a display strip containing some data. It does not stand for anything else. And every strip contains a number of layers that actually display data on top of each other, or behind each other, in front of each other. Now I'm going to create a new strip. I have to do this. I'm going to explain this in a minute. And I'm going to load this object, this sequence into this layer. And now we're looking into A in the first strip, and A contains one sub-object, which itself is a sequence again. And in the second strip, you're looking into this sequence. So if I move this around in the topmost layer, the 2 sub-objects move as well. And if I drag them, they change the duration of their mother object. Therefore, the appearance of the first one changes. Okay, so these are not copies. These are not different instances, but are actually the same objects. They are just being represented in another fashion. Okay. What we are actually seeing here is layers, strips containing layers, which contain container views displaying data. So every layer has one plugin assigned to it, which displays data. In this case, it's a plugin called Volume Standard Container, and these are the container views visible so far. There's an automation container for displaying automation data, although the only thing one can do with automation data in Quince is look at it. There's no plugin actually using it, but so far. There's a send container displaying send deviations, an envelope container for volume envelopes, a frequency standard container with the frequency on the y-axis in a linear way, glissando container for editing glissandi, mark container just for editing for markups, pitch container with frequency in a logarithmic scale, pitch curve container for graphical display of pitch curves, pitch grid container for pitch quantization, time grid container for time quantization, and the already introduced volume standard container with dates built on the y-axis. Okay. And actually these little boxes are plugins too. They are called child views, and the behavior of those is, so to speak, is optional as well. For instance, that they display, if they are representing a sequence, they show the number of sub-events with a little red number. It could be a tiny version of the sequence in graphical display or anything. Okay, another form of plugin is a function, and all the functions come together in the pool. And on the right side of the pool, here are all the functions. And to use a function, I have to double-click on the function name. For instance, legato. The legato function is used to extend the duration of objects to the start point of the next event in the same sequence. And if I double-click on the function name, the function loader is open. This window we see here, and that's an instance between the function and the object, telling me what kind and what number of objects the function needs to operate, and what the function needs the object for. Because it can happen that I have a function that needs multiple objects of the same type for different kinds of to play different kinds of roles inside the process. And this is what the purpose slot here is for, telling me what the function will do with this object. Now, and if I want to apply the legato function to, say, this object, I have to select it in the pool, click on load, and then I can press action. And now the duration of the first event changed so that it's exactly at the start point of the second.
But that's within that object. Because I think it was the top object you were actually applying the function on, the number 2 object.
Yeah. Let me just change the name. This is B. They are untitled. So what the object I executed the function on was the object B. Yeah? And the object B is this one. The one we're looking into in this
Yes, it's
layer.
implicit control.
Yeah.
Okay.
Yeah.
Mm.
So
So
actually,
you're not manipulating the object itself relative to other objects. You're manipulating
exactly,
something.
exactly. Mhm. Yeah, we are looking into the object, and we are in most cases editing the contents of objects. Exactly. Yeah.
So what happens if the content is a sub? Has a
A sub-object itself
Yeah.
doesn't matter. Doesn't matter. It's just
Every lower hierarchy will be affected.
yes.
Okay.
Yeah, because actually the start point of this object in the object B is 0. The start is 0, but it has a parameter called start offset. This is this one, and this is exactly the start value of this object. If I move this, the start offset of this value changes. Yeah? So it's bound to its mother object. Also, I can, of course, I can shift this to the right, which does not affect the start point of the mother object, but does affect now the real start parameter of this object. So if I would apply the legato function to an object containing sequences, it would simply extend the duration of the sequence without changing any duration of its childs. But if I had a function that actually moves the objects, for example, time quantization, it would certainly move all the children as well.
And now you sort of lost. You have to apply a function again if you want to have. What happens if you apply a function now with overlapping objects inside?
Yeah, it's good. It's a good question. And the perfect opportunity for me to show another way to select the function, because if functions only expect one input object of type quince object, they're also available in the selection menu, and I can select them and apply the function right from here. And I do legato. So, okay. There's another function I'm going to show you, a very simple one, and after that we can do something more exciting, and it's called align on volume. And align on volume is very simple. It simply sets the volume parameter of all children of an object to the volume level, to the volume value of the first object. So if I select this and select align on volume, they're all on the same level, the value of the first object. Now we've seen how we can fold objects into sequences, and something very similar can be done with functions as well. As I can combine functions to a function graph, and this is what the function composer is made for. Here I can choose two functions. Let's say I want to start with legato, and this is my first function, and then I can select a second function. In this case, it's align on volume, and it could be the case that the function expects two input objects, the second one. So the input, this menu is the slot where I want to connect the both functions. The input, of course, the input slot of the second function has to be of the same type, has to expect the same type of object that the first function gives as its output. But then I can choose which input I want to use. In this case, there's only one option, so not much to do here. And now I can assign a name. Let's say leg align. I can do this. And now we have a function graph added to our list of functions down here. And that's actually a little XML file, residing somewhere on disk, just describing this kind of connection. And now I can, I already messed it up. Very good. and now I'm going to apply this to this, our new function graph to this object, to the object B. Go to align, I'm going to use this object, load, and action. And now both tasks have been done in one step. And since a function graph actually behaves just like a function, you can combine a function graph with another function, and a function graph with a function graph, and build big trees of functions. Which in some cases leads to problems regarding the names of the function graphs, as you can see in this case. Okay. In quince so far there are 5 types of objects. There's the quince object, which we already saw. It's the most basic object and the superclass of all others. There's data file, which is just a reference to a file on disk, nothing else. Audio file, which is a reference to a file on disk that knows that it's supposed to be an audio file. There's an envelope for volume envelopes, and a pitch curve for displaying pitch changes over time. We're going to come across all of these in a minute. So far, it's not possible to implement type definitions as plugins, but that's planned for the future, so that you can build your own types and plug them right into quince, which only makes sense if you write your views and functions for them as well. But if you're seriously thinking about implementing a type, you shouldn't have a problem with writing a function. Okay, now I'm going to add an audio file to my session, and I have a new object called BF, just like the audio file on disk, with the type audio file. And this knows nothing except where the file is living on disk, and that it is an audio file. And as you can see on the right side, there are not many functions that can actually work on audio file objects. Everything is gray except for one function, audio to envelope. I'm going to open this, load the audio file, click action.
That's your MTC.
No. This is.
Is that what you were doing?
No, I just rendered an envelope from the. I just extracted the volume envelope from the audio file, and I can now choose an envelope container. And now he's complaining because the envelope container cannot display the object that was loaded in the day before. Yeah. And I'm going to load our envelope now. This is the envelope of the audio file. And not a waveform, an envelope with a changing amount of detail depending on the zoom level. The more I zoom in, the more detail I can see. Okay, and to demonstrate the whole layer idea, I can create a new layer on top of this container view, and now I can start putting events in place, just where I think they are appropriate. This is actually how I work with quince. I have an audio file rendered into an envelope, and then I can see and listen and put things into place. There's also another way. The audio file I just opened is a little flute piece from Burkina Faso, and I made a frequency detection on it. There's no pitch detection algorithm in quince so far, but I can read Spear and Praat output. And I made an FFT in Spear, and I'm going to load the output from Spear. And now I have the new sequence, DF, with one sub-object for each FFT slice I made in Spear. That's much too much data. Maybe it's a little faster than before. one thing that is really mysterious for me is that the same operation carried out at different times takes different amount of time. I don't understand at all. I come across this every day.
Maybe by using spear or any kind of FFT tool.
No, I mean in quince, inside quince.
But do you know, it might depend if you have other programs running at the same time. So you have to page out the names.
Maybe. I don't. I mean, it's the same work. It's the same amount of work you would have to do. Okay, so this is much too much data. I have to reduce it somehow. And first of all, I'm going to select only the loudest voice, so to speak. There's one function. It's called one voice loudest. This is supposed to do the trick. Hello. Okay, I'm going to start over. I didn't mention that quince is still in beta phase, did I? Okay. Just to show you what I meant. It's faster, isn't it?
This is good.
No, well, until now, I don't know. Doesn't matter. So import frequencies. And one voice loudest. So, bam. Ridiculous. Okay, now I have one voice, but it's still too much data for editing. And there's another function. It's called join by frequency, and using it I can combine events that have a frequencies in a certain range. For instance, 25% of a semiton. What you can also see here is that a function can actually have its own interface. It doesn't have to stay hidden. It can also come with its own interface. So I'm going to reduce it. I'm going to combine.
Yeah, can I just interrupt you for a second?
Yeah, sure.
We've got a problem that is the restaurants around the Hochschule all are closed today because it's a Sunday before a public holiday. We didn't really anticipate this. The suggestion at the moment is that we can order some pizza to eat here in our cafeteria, and I was just wanting to check if that would be in the interest of any of you guys.
So I'm going to combine successive events which are in a frequency range of 25 cents. Okay. So now this is looking much better. But this is not necessarily, being an instrumental composer, this is not necessarily quantized to eighth tones. This is I just combined them, but it's not said that they are on the right pitches for instrumentalists to read. So I'm going to start with quantization now. And basically, if you quantize something, you need an object you want to quantize, and you need another object you want to quantize onto. You need a grid. And this can actually be any sequence. If you're quantizing time, you can just quantize on any sequence you extracted from an audio file, or you just clicked or something. Same is true for the pitches, but you can also create a regular grid sequence using the function create grid sequence. And there are two tabs here, one for time and one for pitch. Only tempered pitch, tempered scales are possible so far, but I'm sure there's something else to come. And this is the time, but I'm going to start with pitch, and we said 25 cents. Okay, now I have a pitch grid with one sub-object for every possible frequency. And now I'm going to quantize our sequence onto this pitch grid. I'm going to rename this first. Ready for Q. So there's a function called pitch quantization. I'm loading the grid and my object. Say action. Now I get a copy, quantized, pitch quantized copy of my original sequence, which I can have a look at. And we can have a look at the pitches, pitch container, and now we can limit the range we see to 76, and I think it was to 90. So, okay. And to look if we if any mistakes happen in the quantization process, and if this is actually okay aligned with the original frequencies, I can create a pitch curve out of my original sequence using the function sec to pitch curve. And then I can create a new layer in my strip, load the pitch curve container, and see the pitch curve drawing. So this looks quite okay, I think. Now we can do a similar thing with the time. I create a time grid sequence. And if you think of a second, one second as a quarter node, this would be a second or quarter node. This would be an eighth node, triplet, 16th, quintuplet, sextuplet, and so on. Okay. And now I'm creating a grid of, I don't know, 30 seconds and quintuplets maybe. Oops. We have it on tape. It took like half a second last time. Okay, this is the time grid, and I'm going to load this into the time grid container. So now what you see here is a red line for every point in the grid that objects are going to be quantized onto, and the colored areas are areas from which objects are being quantized onto the red point. To clarify, if I had an event here, the start would be pulled onto this red line, and the duration would be changed so that it would be on this red line. But it's basically just another sequence with one sub-object for each point in the grid. And now I can, I don't need this anymore, I can time quantize our sequence, time quantization with the grid, load the pitch quantized version. And go. So this is it. Oops, okay, this is pitch and time quantized. Now we have some duplicates which I want to get rid of, and again I choose the loudest version. Okay, now I have one voice with time and pitch quantization. And one thing I can do with it is to export it to Lillipond. Do you know Lillipond? Any chance?
Just heard of it.
Ah, okay, cool. Let's say I want quarter note 120 BPM. That's it for now. Choose this one. Yep. This is Lillipond. This is the code we just generated. I'm going to convert it into this. This is quite wrong because I forgot to tell him that I wanted to see pitches. I want pitches. Okay. Pitches, please. I have to choose this one first. Okay. So pitches with automatic quarter tone notation. I can also add dynamics if I want to. I can map dynamic expressions into the object by entering individual values or changing the spread, the distribution. And now every sub-object has another parameter called dynamic expression with an appropriate value for it. And if I export this to LilyPond, I could also want dynamic expressions on the bottom, and I also want cent deviations on top, for instance. Yeah, okay. Now I get cent deviations and dynamics. So this is one way to go. Talking about ways to go, I can this audio file I used to create my envelope earlier. I can also, of course, play it back. And there's currently two players that can play back sequences. The one is the audio file player that's it's able to ask it asks an object, a quince object for its media file parameter, and if it's an audio file, it's going to play this back. And the other one is the csound player. This is actually why I'm here. But I'm going to show you the audio file player first. Again, I just maybe we just start with a fresh session. Okay. I load an audio file, the BF, and when we drag an audio file into a DAW, we just think and talk about it as if it was an audio file we drag into it, but it's really not. It's just a reference. Same is true for quince, but in quince you have to create these references yourself. Again, via a parameter of an object. The parameter to go here is the parameter media file name, because the audio file player will look for this player, and the video player, if there would be one, would ask it for a video file. There are currently two mechanisms to link an object with an audio file that's built in, so to speak. One thing is if I have an audio file in the pool and I have it selected, there's a tiny text field on the left bottom side here showing the name of the audio file. That's normally showing no reference. But if I have this selected, I have a reference to an audio file in the back of my hand, so to speak. And if I create a new object, this object automatically has the parameter media file name with the name of the referenced audio file as its value. This is much too long, I think. Zoom a bit in. So, and if I play this session now with the audio file player, this little object will play back the referenced audio file. This is
the duration of this one, how does it relate to the audio file length?
It doesn't. It's just this blue one is just an object, and I give it a duration, and well, I have to make sure it's not longer than the audio file. If it's supposed to be really linked, I have to make sure myself. And I can give it another parameter called media file start, which acts as an offset into the file. So this is pretty much like one would expect it from a DAW. And if I copy it, I have multiple instances of, and the volume being dependent on the y-axis. There's one other way, because when the audio file player plays a sequence and comes across an object that does not have a reference to a media file, it asks this object's mother objects for a reference for an audio file. Maybe it should inherit the reference from its mother object. So what we can do is create a new empty object with a reference to the audio file, just by clicking on this button here, new object for audio file. Now I have a new default object with a reference to my audio file. I load this into the view, and now we see nothing because it's empty so far. I have now no reference to the audio file, but I'm creating new objects anyway. And these objects now act as windows into the audio file. No? So these are just two ways of working with audio files.
It's like a gate.
Sorry?
It's like a audio amplitude gate.
So,
Yeah, sort of. Yeah. But you it's not dependent on the volume actually. But yes. Yeah. Okay, and the second player, why I'm here, is the csound player, and the csound player is actually an instance of csound wrapped in a player plugin. And when I go for the settings window here, you get the org and score tabs with our currently visible sequence in the csound score representation. That's true for all players. The players always play what's visible in your project window, not what's in the pool, only what's visible. So this is the csound score representation and an orchestra with 4 default instruments, very basic instrument. The first one is the audio file version. It's basically the same thing that the audio file player does. Simple click just to hear rhythm, glissando on a sine tone, and simple sine tone. It's just a basic set. And we can try this. I'm going to create a new strip and delete the old one to get a pitch container. Okay, create a new object. This is logarithmic frequency, and the numbers are MIDI pitches. We can use it like this, pitches, and play. Okay. Yeah, thank you. We are a bit too loud, obviously. Much better. Okay. Sorry. Okay, so using this pop-up menu here, I can change the default playback mode for my events. And if I want to switch between them for individual events, there's one parameter that will override the default csound mode, and it's called csound mode. Oops, csound mode. And let's say I want the second event to be played back by a click. The mode is clicks, so the second one, despite the global default csound mode, is played by click. But of course, you can also add your own custom instruments. We could type the instruments directly into quince, into this orchestra. It's saved with a session, and using another parameter called csound instrument number, and the appropriate number of our instrument we wrote here, we can access the individual instrument. That's it so far. What I forgot to mention is that quince is not only beta; it's also in the public domain. It's an open source project. Unfortunately, so far only running on macOS X. It's written in Objective-C, and I'm still hoping that someday I will manage, or someone else will manage to port it to Linux via GNU step. It's the open source version of Coco, but so far I can't see when I will be able to. Any question?
So your intention is actually to start out with normally sort of an analytical approach to.
Yes. Yeah.
To take information out of existing material and then reuse it or try to use it.
Exactly.
That's sort of the motivation for the entire.
Yeah.
That's interesting.
Can you show the pitch container and, for example, gain or the volume, the view at the same time?
No.
You can't.
No.
You have to
Not in the same strip. You can, of course, you can. You in one strip you always choose with the first layer. You assign a container view to. You choose the parameter that's going to be displayed on the y-axis. And you cannot display decibel and frequency on the same axis. But you can, of course, load the same object into another strip with another layer, with another parameter.
Yeah.
For instance, we can have, I think it's this one. Let's call it 3D. And, okay, thank you. Here we see the pitch. Now we create a new strip with the volume standard container, load it, and this is the same sequence. Yeah, it's the same objects, but it's volume here and pitch there. And we can even go a step further and say, okay, I want the send container to display the send deviations to MIDI pitches of the same sequence. So this is a very tiny change for the pitch container. It's not even visible actually. Now it is. Yeah. You see? Yeah. So now we see the same sequence in 4 dimensions at once. Ha! Yeah. And this is exactly how I work. I showed an example before. I'm going to do it again. Recent.
Yeah, it could be interesting to follow the sort of the output from the import file through the analysis, if possible. See what happens.
For instance, this is a file I've been working on recently. It's a neighbor of mine working in his flat with a, what was the word? Floor sander?
Yeah,
with a,
floor sander.
To polish the floor.
Oh,
To sand the floor.
Yeah.
Yeah.
So you see the pitches here, and this is the glissando container. You can edit the glissandi. The same object on the time grid, so that I can see where the events are going to be put in the end. Notation, if it's making sense. Yeah. And the output of this would look like this. Now with send deviations and even glissandi.
Could you do like, and you analyze the audio file and then process it and output it? You can do this?
Now? Yeah, sure. Why not?
So what,
Yeah, let's do the flute again. Why not?
so what's the intended instrument playing this example, for instance?
Actually, this exact thing is going to be played in a month by trombone.
Trombone.
Yeah.
Obviously.
Okay, let's go for the flute. Import frequencies. This is the same thing we saw earlier. The analysis I did in Spear. And normally I'd now use this is exactly what this huge, which I made this huge thing for. But we let's do this from scratch. So first I reduce the data. I pick only the loudest parts of the analysis. Then I'm going to join the frequencies together. I think eighth tones are okay, so 25%. Then I want to, let's say we are interested in glissandi, what we saw a moment ago. And what I want to extract is the vertex points. Actually, I don't want I don't need information all the way. I just need the points where it's going to change the direction. And there's a function for that. It's called extract frequency vertexes. So now I have vertexes. We can have a look at it. Let's make a pitch curve lying behind all this. Select the pitch curve. Okay. Again, 76 to 90. And now we can put in the pitch Yeah, glissando container, why not? And we use this one. So, this already looks okay. Now we could do the pitch quantization again 8th tones. Pitch quantization. Grid and the victim. Okay, let's have a look. Okay, now I want this whole thing to. I don't want gaps. I want it to be legato, so I choose legato. Okay, and let's do some time quantization. Time. Okay. So now I have the time quantized version. Again, I have to get rid of some duplicates. Okay, and normally I would spend hours now to adjust the glissando, so they're really cool and sound good. I'm skipping this now and go for Lillipond, for example, with pitches and glissandi and some deviations on top and faster, please. Like this. And now put here. Okay, I think I forgot to click on the glissando button, did I? No. No, I didn't. That's a pity. I don't know what just happened. Something happened.
But if you press play in Quince now,
Yeah, that would be interesting,
Yes.
wouldn't it be?
is it
Okay.
possible to play more than one? Let's say if you have imported a sound file, an
Yeah.
audio file, and then you do a lot of processing, is
Yeah.
it possible to play the original file together with the? You could sort of mix them, to try to
Yeah, it
verify your
should be
action.
actually. This is quite new. I haven't tried it yet, but we're going to try it now. So let's make sure we get a csound player playing this as glissandi. Should work. Wow, didn't look too good, did it? Do I have another instance of Quince open? No. I don't know. Something has just happened. The glissandi didn't work either. Something has happened. But it should be simple, really, even because if I had another sequence lying here with one long object linked to the audio file, I could assign the csound mode audio files. Then this event would be played with the audio file, and I could listen to my glissando, to my pitches as well. I don't know what just happened. I can't. It's just maybe if I save this and try again. So bye bye. So we want csound player, we want glissandi. It's called audio files, and this one, csound mode audio files.
It's a demo.
But it's all there. It's all there. Yeah. I know why. Because this one has to have. Yeah, shit. Sorry. So this one has to have pitch and frequency value to show up here. So now it's okay, isn't it? There's one tiny problem, and this is the p fields, or the parameters that are shown in the csound score are all parameters that visible objects have in common. To make sure the p field order is correct. So I would have to create dummy parameters in my glissando sequence. All the objects would have to have a parameter that's called media file name. Otherwise, I can play the glissandi now, but I cannot not play the audio file because he has no media file name parameter in my csound score, because not all of the visible events have this have the audio file parameter. So I would have to.
I think that's sort of a request.
Yeah.
Future.
Yeah.
It could be interesting to monitor. Really nice.
Okay.
Can't wait to try it out.
So it is available now?
It is available for free on my website in binary form, and the sources are on GitHub also.
On
GitHub.
Okay, yeah, sure.
Yeah. And usually the sources are more up to date than the binary releases.
I'm just a PC guy, so sort of. We have Macs in our labs, so it could be interesting to try.
And I'm really trying to make lots of releases and to fix bugs all the time. So if you come across something, please write to me.
Okay.
Thank you.
Thank you.
Thank you so much.